Question number 3. A satellite moves in a circular orbit around the Earth at a speed of 5 times 10 to 3 meters per second. Calculate the altitude of the satellite above the Earth's surface. So we have to always start drawing our condition. So let's say this is a satellite orbiting the Earth. Okay, so this satellite is having velocity. So this is the velocity of the satellite orbiting the Earth. So the question A, okay, we need to find the altitude. So altitude is the height of the satellite from the surface of Earth. So we want to find height. Okay, so for this kind of question, we have to always use the equation for velocity is square root gm over r. So hopefully we still remember that our r is equal to the summation of radius of r plus altitude. So radius of r is here inside the Earth plus the altitude, then we can have our r. Okay, so now the equation can be written in terms of gm over r plus h. So this is the velocity. Okay, let us now substitute all the values. So we have 5 times 10 to 3 for the velocity. Square root g is 6.67 times 10 to minus 11. Mass of Earth is 5.98 times 10 to 28 divided by radius of Earth is 6.4 times 10 to 6 plus altitude, the one that we want to find out. Okay, so we square both sides so that the square root on the right side can be eliminated. So we multiply these two values, then we have 4 times 10 to the power of 14 over 6.4 times 10 to 6 plus h. Then we multiply everything in here with the number on the left side. Then we'll have 1.6 times 10 to 14 plus 2.5 times 10 to 7h equal to 4 times 10 to 14. And finally, your h is equal to 9.6 times 10 to 6 meter. For B, the question asks us to find the period. So we apply the equation for period. T is equal to 2 pi square root r cubed over gm. So please remember, our r is radius of Earth plus altitude, the one that we found out just now, over gm. And once again, we substitute all the values. Okay, calculating all the values. Finally, you'll get your time is equal to, or period is equal to t 2 times 10 to the power of 4 seconds.